Hi everyone. Today we're going to look at some radical expressions, so square roots, cube roots, fourth roots, and we're going to learn how to simplify them. Now we're going to learn that we simplify them so we can compare different radicals, and it makes it easier to use them in future problems. So first we need to explore what's bigger, square root of 73 or 9? 2 times the square root of 35 or the square root of 120? So now the easiest way we can do it is put in our calculator and compare the decimals. But we also know that 9 is the square root of 81. So square root of 81 is 9, and this is only square root of 73. So 9 should be bigger because 9 is square root of 81. And the bottom one, same thing. The square root of 120 is about 11 because square root of 121 is 11. So this is less than 11. And we know this is about 6, so 2 times 6 is 12. So we can compare radical expressions by knowing some of our perfect squares. The square root of 36 and square root of 121. And the top example, we have square root of 81. Now, this is going to bring us into a bunch of irrational numbers. So irrational numbers, okay, if I make it to a decimal, it doesn't end and it doesn't repeat. So pi is a constant, e is a constant, square root of 2, okay, is 1.4, and the decimal keeps going, no repeating, cannot make into a fraction. So radicals are a big part of irrational numbers. Now the parts of a radical, we have the index, which tells us whether it's a square root or a cube root. We have the radicand, which is the number inside. And we have the radical symbol, which is that giant checkmark looking item. And this whole thing is called a radical. So if I refer to a radical, I mean the whole entity. So the rules for simplifying radicals is if I can factor a number down, then I can simplify it. So square root of a times b, I can simplify it into two parts and simplify both of those parts. So 75, I'm going to make a factor tree for it. And I see I have 5 times 3. So really I have the square root of 5 squared times 3. I can break that down into two parts, and I can have the square root of 5 squared and the square root of 3. And the square root of 5 squared is just 5, because the square root and a square are going to cancel each other out. So really I have 5 times the square root of 3. So if I have a square root, if the index is 2, we pull out a pair of numbers. Now if the index is 3, we do the same thing. We take the prime factorization, we write it out, but now I'm going to pull out groups of 3. So I have one group of 3, and that's 3 threes. So this one, this cube root and the cube are going to cancel out. So I have 3 cube root of 2 squared, and I'll just evaluate 2 squared to get 3 cube root of 4. So that's how we simplify radicals. We use the factor tree, and then the index will tell us how many groups we can pull out or our group size. So if it's pairs, we have to pull out 2 at a time. If it's cube root, we have to pull out 3 at a time. In my next video, I'll show you another example of how to simplify more radicals.